We're doing number 23, which says given 3I is a complex zero of f of x equals x cubed minus 2x squared plus 9x minus 18. To find the other zeros using long division with the given complex zero and then the conjugate of it. Okay, so we know as of right now x equals 3I. And we always know that the conjugate is the opposite. So minus 3I. And now we have two of the zeros. And since x cubed is the highest degree, the most we can have is 3. So since we have 2, there's only one more left. So in order to find it, we're going to factor these two zeros together and then use those to divide into the original formula. So put it into the formula x minus r, and since zeros are meant to make x equal 0, so obviously x is going to equal r, so r equals 3i and negative 3i. So plug those in, and we get x minus 3i and x plus 3i. Okay, then you distribute and so on. And the end result, when you do it all, will be x squared plus 9. Because x times x is x squared, and then the 3i and minus 3i and plus 3i will cancel out, and then when you times them together, you'll get plus 9. Okay, so now that we have that part, we can put it over here to divide the original formula. So let's write it here. X cubed minus 2x squared plus 9x minus 18. Now we have to multiply this number right here, this front one, so it cancels out this one. So it's going to have to be x, because then x squared times x is x cubed, and then x squared times 9 is 9x. So we're going to put it over here to the matching matching degree. And then you always subtract the entire part. So now that's 0 and that's 0. So now we have to drop down the other two to get rid of them as well. So negative 2x minus 18. And if this is in fact part of it, the function, then this should cancel out perfect. So I think minus 2 will get negative 2x squared from it. And then negative 2 times 9 is negative 18. You put parentheses and you subtract that and cancels out. And what's left is x minus 2, which is the last factor. So for starters, our last 0 is 2 because when you set x minus 2 to 0, x equals 2, as you see there. Alright, so we have that part done. Now they want us to put complex system, I should say. So let's write it out. Complex. So this one's going to include imaginary, so we can just write it out how we had it before. So x minus 3i, x plus 3i, and then the one we just found, x minus 2. So that's the above function factored in the complex system. Now, for the real system, basically there can't be any imaginaries in it, so all we're going to do is just plug these two back together, and since we already have it, we'll just go back up, and it is x squared plus 9, and then the other one isn't imaginary, so you can put it there. And that's how you put them into complex and real systems. And that completes the problem.